So on number 1, what is difference of squares? So they say here's an example. Which one is kind of like this? The first thing you should probably pay attention to is a difference. It's subtraction, right? So which of these are subtraction? Has to be A or C. B and D are out because they're addition. And perfect squares. Okay. Now this includes variables. Okay. Perfect squares includes variables. So if you look in here, you can see the variable here is squared. The number is 1, and we have a 9, which is 3 squared. Here we have a 5 squared and a 10 squared, but the variable is not squarable, meaning it's basically an odd exponent. We can't take the square root of that. So C is out. That leaves us just with A. That's the only other difference of square there. Okay. Which of these is completely factored? Okay. So one way to do this is to actually do the whole problem. Another way of doing it is looking at them and see, well, if it's completely factored, that means I can't do anything else. But if you look at A, you should recognize that that's a difference of squares. That's even exponent, both 1 squared, so that could be factored more. So it's not A. And B, same thing. If you're looking at all these, yeah, that's a plus, can't factor these. But the second one, once again, or the third one, is 1x squared minus 1, or 1 squared. So that can be factored, so it's not there. And this is one of those you have to keep on factoring and factoring and factoring, and eventually you do end up with C. Okay. You end up with C as your final answer, because these can't be factored anymore. 3, you just have to go ahead and factor it and see what happens. In this case, start with a GCF. 8 goes into both. X, there's an X in each of them, so 8x is a factor. And whatever's left over in the parentheses is also another factor, which would be x squared minus 3. Now, does x squared minus 3 factor even more? Does that go to like x plus 3, x minus 3 in one of those? No, 3 is not a perfect square. If it was 4 or 9 or 25 or 16, then we'd keep going. But 3 does not work, not a perfect square. So we have 2 factors. We have 8x as a factor, and we have x squared minus 3 as a factor. So both of these are factors, and these are not. So a factor, think of multiplication. If you're multiplying it, it's a factor. So since it's 8x times x squared minus 3, that makes both of these factors. Okay. Let's go back up here. Okay, we got an area of a rectangle. Find the sides by factoring. So even if we don't understand the rectangle and the area and all that stuff, you understand that you know how to factor things like this. These look like possible answers, so go ahead and factor it. GCF, no. Attic basement, what 2 numbers multiply to negative 24x squared and add to negative 5? And you end up with, what is it? 8 and negative 8 and 3. Okay. So we have 2x squared plus 3x minus 8x minus 12. Factor the first 2. Only thing that comes out would be an x. So we're left with 2x plus 3. Factor the second 2. They both have a negative. Take a negative out. What's the biggest number that goes into 8 and 12? We get 4. So we have left over 2x and plus 3. So my 2 factors are 2x plus 3 and x minus 4. And looks like only the 2x plus 3 is right there. Okay. Ooh, which one's prime? Number 5. We got, let's see here. Well, here's a GCF right away, so we know that's not it. What about B? Does that have a GCF?
Yes.
Yeah, the variable. So A had a GCF in the numbers, B has a GCF in the variables, they all have a C, so that's not prime. C, that's a 1 squared and that's an 8 squared, so can we factor this? No, because it's addition. It's not a difference. It's a sum of squares instead of a difference of squares. Oh, so that is prime. Yeah. You can't factor it. It's a sum. And the second one, I mean the last one we can look at, well, what two numbers multiply to negative 10a squared and add to 3a? So we can get negative 5a and 2a. So since we can find these two numbers, it must factor. So we know D is not it either. So yeah, C is the only one that's prime, cannot factor. And lastly, okay, very similar to number 4. Just go ahead and factor it and see which ones work. Okay, so what two numbers multiply to 12x squared but add to 13x? So 12x and 1x. So we have 2x squared plus x plus 12x plus 6. Factor out x out of both of them. Left with 2x plus 1. Factor out GCF of the second two, which would be 6. 2x plus 1. So our two factors are x plus 6 and 2x plus 1. So 2x plus 1 is a factor, x plus 6 is a factor. Neither of the others are. There you go. Let's look at the back. Just factor completely. Remember, we're not going to tell you what method or what to use the x or to do difference of squares or do GCF first. You just have to know factor means do everything in a certain order. So GCF is always first. What do these have in common? So take out 7. Any variables in common? No, y, x, xy, nothing in common in all of them. So 7's the only thing you can take out. Work backwards or divide by 7 everywhere. And you'll get this. Just dividing everything by 7. If we have 3 terms to start with, you'll have 3 terms in your parentheses to finish. Anything else we can do here? There's 3 terms. Should we try using the box here? Or try using the x here? Usually, if you notice, every time you use the box, there's a certain pattern to the variables. This does not fit that pattern, but try it anyway. Try using the x and you'll find it doesn't work and you'll stop anyway. About 8. What's the GCF of these two? Yeah, 2's in both of them. There's an n in both of them, so you got to take out a 2n, right? And then what's left over? 7 minus 4n. Can this be factored more? 7 minus 4n? No. 2 terms. Is it a difference? Yes. Are they perfect squares? No. We don't have a to the second power, and 7 doesn't work either. Okay? So hopefully that'll get you started. We'll have the rest of the problems on the next video.